Welcome to AlphaNumericTricks. In this video, we are going to see the detailed answer for MCQ questions part 2 under the topic Eigenvalues and Eigenvectors. The test your score video is available in the description box. If you want the detailed answer, you can check it here. First question, if A is any square matrix, then which of the following is a skew symmetry matrix? The options given here are A plus A transpose, A minus A transpose, A transpose and A transpose A. Now we have to choose which is the correct one. And now using the definition of a skew symmetry matrix, we have to choose the correct answer. The definition for skew symmetry matrix is Aij is equal to minus Aji. Using this definition only, we have to choose our answer. Now we take the matrix A to be, so that is another problem. A is any square matrix, we can take it. So A is equal to 1 minus 2, 1 and then 3, 2 minus 1 and 5, 2, 3. Any matrix you can choose it. Now we have to write the A transpose for this matrix. A transposes you have to write columns into rows and rows into columns. Anyway, you can write it. Now we write this column to be a row. So 1, 3, 5 and minus 2, 2. Second column is written row wise and third column is 1 minus 1, 3, which is written here 1 minus 1, 3. Okay, so this is your A transpose. The first option is add these two matrices. So find out A plus A transpose. A plus A transpose is equal to, we have to add these two terms. 1 plus 1 is 2 and minus 2 plus 3 is plus 1 and 1 plus 5 is 6 and 3 minus 2 is 1 and then 2 plus 2 is 4 and minus 1 plus 2 is plus 1 and then next we have, that is corresponding terms you have to add it. Okay, 5 plus 1 is 6 and then 2 minus 1 is plus 1 and 3 plus 3 is 6. When you are adding these two matrices, we get symmetry matrices in this 2, 4, 6 is there. 1 here Aij is equal to Aji term as we obtained. That is A12 is equal to A21 value and A13 is A31 value, A23 is A32 value. So this is a symmetry matrix, but a skew symmetry is A, that is Aij is equal to minus Aj. So next option we take it to be A minus A transpose. So A minus A transpose is equal to, we check it out, 1 minus 1, it becomes 0 and here we have a minus 2 and here you have minus 3, minus 2 minus 3 is minus 5 and then here you have 1 minus 5 is a minus 4 and the next one is a 3 minus of minus 2 is plus. Okay, 3 plus 2. 3 plus 2 is, what is 3 plus 2? 3 plus 2 is equal to 5 and 2 minus 2 is equal to 0 and then minus 1 we are subtracting. Okay, minus 1 minus 2 is equal to minus 3 and the next one is 5 minus 1 is 4 and then 2 minus of minus, it becomes plus. So 2 minus 1, 2 minus of minus 1. So 2 plus 1 is 3, write it here and then 3 minus 3, it becomes 0. Okay, so we get the matrix. So here you have here minus 5 is there, here plus 5 and minus 4 plus 4 minus 3 plus 3. So Aij is equal to minus Aji. So A minus A transpose is a skew symmetry matrix. When A is any square matrix, then this A minus A transpose is the skew symmetry matrix. A plus A transpose is a skew symmetry matrices. That is A plus A transpose is symmetry matrix. A minus A transpose is a skew symmetry matrix and A transpose is not at all a symmetry matrix. So leave it. We get the answer. So leave it. Next one. Now we'll pass on to the next problem. All the eigenvalues of 2 by 2 matrix are non-zero and one of the eigenvalue of A is 0. Which of the following statement is true? There are 4 options are given. In our problem, the matrix is given in terms of A11, A12 like this. So we write the general matrix. A is equal to A11, A12, A21, A22. This is our matrix, we take it. And here the condition here given here is all the entries of the matrix are non-zero and one of the eigenvalue of the given matrix A is 0. So we have to use the property of eigenvalues for this problem to get the solution. By the property, that is eigenvalue of a matrix A, eigenvalue of the matrix A is equal to determinant A, that is, product of eigenvalue of the matrix A is equal to determinant A. So product of eigenvalue of a matrix is equal to the matrix determinant A. This is one of the property of eigenvalue and eigenvector. That is lambda 1, lambda 2 is equal to determinant A. We take it that is the eigenvalues of the given matrix B, lambda 1 and lambda 2. So that is equal to determinant A. Now by the condition, one of the eigenvalue of this is equal to 0. So 0 is equal to determinant A. So we have to find out the determinant value for the problem, that is given matrix. So we have to use a cross multiplication, A11, A22 minus A21, A12, A11, A22 minus A21, A12 is equal to 0, which coincides with the option B, A11, A22 minus A12, A21 is equal to 0. So option B is the correct answer. By mistake, I gave both the A and B options the same thing. So if A is we change it to be A is the option A11, A22 plus A12, A21 is equal to 0, then B is the correct answer. Suppose if it is not given like this, that is it is minus is given, then both are the correct answers. Okay, because both are the same, that's why both are the correct answers. But if we change it to be plus, then this is the B is the correct answer. Next question. The characteristic roots of a matrix A is equal to 1, 0, 0, minus 1, minus 3, 0, 9, 0, minus 1 is. Now we have to find out the characteristic roots of this matrix. What is characteristic roots? Characteristic roots is otherwise known as eigenvalues. So here this is an this matrix is a lower triangular matrix. So you can write this diagonal elements are the eigenvalues. So 1 minus 3 minus 1 is the correct answer for this. And next one, for which value of x the following matrix A becomes singular? A is equal to 6, 0, x minus 1, 0, 1, 4, 2, 0. So which is the correct answer? That is, for what value of this and the value the matrix A becomes singular. What is singular matrix? For singular matrix, determinant A is equal to 0. So we have to find out the determinant A for this. 6, 0, x minus 1, 0, 1 and 4, 2, 0. We have to find out the determinant for this matrix. So determinant of this matrix is equal to 6 into, that is you have to row this first row and leave the first you write 6 and leave the first row and first column. The remaining terms you have to write it. So determinant of this you have to write it 0, 1, 2, 0. And this is 0. Second element is 0 into anything is 0. So it is 0 into, you have to leave this row and column. Remaining terms you have to write it. So this becomes 0. And then plus x into next determinant you have, that is the corresponding rows and columns. Remaining minus 1, 0, 4, 2. This is the determinant you have to write it. So 6 into 0 minus 2 you have plus x into minus 2 minus 4, that is minus 2 alone. So determinant A is equal to 0 given. So determinant A is equal to 0 implies minus 2x, minus 12 minus 2x is equal to 0, or otherwise minus 12 is equal to 2x, or x is equal to minus 6. So this is the correct answer. X is equal to minus 6. When my x is equal to A is equal to minus 6, that is when x is equal to minus 6, then it becomes the singular. The given matrix becomes the singular matrix. Okay. Next we will pass on to the next question. Next question is, The eigenvalue of matrix A is equal to this matrix is minus 3, 2, 6. Then we have to find out determinant A. That is, eigenvalues are the eigenvalue of the matrix is given minus 3, 2, 6. So determinant A is equal to, we have to find out determinant A. Determinant A is equal to product of eigenvalues. Suppose lambda 1, lambda 2, lambda 3 are eigenvalues of the matrix A. Then determinant A is equal to lambda 1, lambda 2, lambda 3. That is minus 3 into 2 into 6. That is, you have to multiply this. Okay, minus 3 into 2 is minus 6. Minus 6 into 6 is minus 36. So, minus 36 is the correct answer. The next question is, what is the sum of the squares of the eigenvalue of A is equal to this matrix? So, this is the upper triangular matrix. So, eigenvalues are the diagonal elements here. This is 0 here. This term is 0 is given. So, eigenvalues are the diagonal elements. So, we have the diagonal elements are, that is eigenvalues of the matrix are minus 1, 6, 2, and then sum of the squares of the eigenvalues is minus 1 squared plus 6 squared plus 2 squared, which is equal to 1 plus 36 plus 4, which is equal to 41. So, 41 is the correct answer. Okay, next question. Next, we have to find out the answer for the next question. Find the eigenvalue of 2a squared if a is equal to this matrix. Here also the 0 is given, so just the eigenvalues are the diagonal elements. So eigenvalue is equal to 4, 2, but we have to find out the eigenvalues of 2a squared. What is this is eigenvalue of a. What is eigenvalue of a squared? Eigenvalue of the matrix A squared is 16 plus 4. That is, you have to square it. Okay. 4 into 4 is 16 and 2 into 2 is 4. So 16, 4, which is the eigenvalue of a squared. But we have to find out eigenvalue of 2a squared. So multiply just by each by 2. So 32, 8, which is the eigenvalue 8, 32. And next question is, suppose the matrix A is equal to minus 1, 3, minus 2, 4 has the eigenvalue 1. Find the eigenvector. Here this matrix has the eigenvalue 1. Now we have to find out the eigenvector. So that is, to find out the eigenvector, we have A minus lambda I into x is equal to 0. Using this only, we have to find out the eigenvector. Here the value lambda is equal to 1 is given. So we have A minus lambda into 1 and I is I, you have, into x is equal to 0. In the place of 1, you have the unit matrix. So A matrix here is minus 1, 3, minus 2, 4 and minus 1, 0, 0, 1, because this is your this matrix. Okay, A minus I is this, into x is x1, x2 is equal to 0. Okay, so here we have minus 1 is minus 2 and 3 minus 0 is 3. Each element is subtracted. Minus 2 minus 0 is minus 2 and then 4 minus 1 is 3. So this into x1, x2 is equal to 0. Okay, so from this we can write this to be both the same matrix you have. So when you write this, 2x1 plus 3x2 is equal to 0. So from this you can write this to be 2x1 is equal to minus 3x2. Take this term to be other side. And here you cross multiply it, x1 by, you take this term to be, that is minus 3 to this side, x1 by minus 3 is equal to x2 by, here you take this minus 2 to other side. So minus 2, or you can write both the terms having minus. So you can write x1 by 3 is equal to x2 by 2. So 3, 2 or 2, 3 is the eigenvector. That is eigenvector x is equal to 3, 2. This is the eigenvector. But in our problem, it is given in terms of the transpose. So 3, 2 transpose, or 2, 3, both on the same. So 3, 2 transpose is the eigenvector of the matrix A corresponding to the eigenvalue lambda is equal to 1. And the next problem, what is the eigenvalue of the null matrix of order 3? What is null matrix? 0 matrix, okay? Order 3 matrix 0, 0, 0, 0, 0, 0, 0, 0, 0. This is the null matrix of order 3, but we have to find out the eigenvalue of the null matrix of order 3. How will you find out eigenvalue? That is A minus lambda I is equal to 0. The determinant A minus lambda I is equal to 0 gives the this matrix. So we have that is null matrix of order 3. So this 0 minus lambda, 0 minus I is 1. So 0 minus lambda is equal to, that is 3, meaning you have a lambda, 0 minus 3 the whole cube you have, okay? That is here you have A minus lambda. So suppose you find out this to be A minus lambda I here, and here you have a 0 minus lambda, 0 minus lambda, 0 minus lambda. So from this 0 minus lambda, the whole cube is equal to 0, or lambda is equal to 0, 0, 0, 3 times you have. So this is the eigenvalue of the null matrix of order 3. Okay. Now, suppose that the eigenvalue of any matrix A is 1, minus 1, 2, then what is the determinant of A is equal? That is determinant of A inverse the whole transpose. Okay. Now the given here given eigenvalues of the matrix A is 1, minus 1, 2. This is the eigenvalue of A. Okay. Eigenvalue of the matrix A. Now we have to find out the eigenvalue of determinant value of A inverse. Okay. So for any matrix A is equal to A transpose, for any matrix A is equal to A transpose. So eigenvalue of A is equal to this, meaning eigenvalue of A transpose, eigenvalue of A transpose also equal to 1, minus 1, 2. But what is a eigenvalue of A inverse? Eigenvalues of A inverse is 1 by 1, minus 1 by 1 and 1 by 2. Or you can have 1, minus 1, 0.5. Now we transpose also, that is A inverse the whole transpose also the same. Now we have to find out determinant. Determinant meaning we have to multiply this. Determinant A inverse the whole transpose is equal to 1 into minus 1 into 0.5, okay, 0.5. What is 1 into minus 1 into 0.5? 1 minus 1, 1 into minus 1 is minus 1 into 0.5 is minus 0.5, which is the eigenvalue of this. So C is the correct answer. Okay, that's it for this video. If you have any doubts, please provide in the comment section. Thanks for your time and thanks for watching. We will see in the next video. Thank you.